Okay guys, this is notes on ionic compounds, and this goes along with chapter 7 in your textbook. Khan Academy has a lot of stuff on this, and any other videos that I find I go ahead and throw in my YouTube channel, which you can find here. If you forget this, just go to my webpage, scienceclass411.com, and go to the YouTube channel down at the bottom. Let's go. Let's go through that again. We've got the electron configuration for sodium. This right here is the electron configuration for neon. So sodium's noble gas configuration is neon plus the valence electron. The valence electron will go away because sodium is unstable. Why are atoms unstable? They don't have full outer shell, full set of valence electrons. So in this case, it's going to lose the valence electron. The electron configuration will look like neon, but it'll have a positive charge because it lost a electron, which is what charge? Negative. So we write the sodium ion. So this is a sodium ion right there. We write the sodium ion with the symbol for sodium and then the superscript of the charge, which is positive in this case. This charge right here has a special name. It is called the oxidation number. That charge is called the oxidation number, abbreviate. Okay? It is always written as a superscript. It is written afterwards. Okay. Now let me show you an element with a different oxidation number. So magnesium with 2 valence electrons is going to lose those 2 valence electrons and look like neon, but because it lost 2 valence electrons, its oxidation number is 2+. Is this easy? So how do I write the symbol for magnesium ion? Mg2+. Now what's different about that and sodium? What do I not have written in sodium? A 1. Never, ever, ever write the 1. If you write the 1, I'll give you detention. Okay, maybe not, but don't write the 1. 1 is understood, okay? So knowing the valence electrons is going to help you understand, is going to help you with oxidation numbers. Why do I have a periodic table up here? Valence electrons. How many valence electrons in group 1? 1. How many in group 2? 2. Skip the transition metals. We'll come to that today. How many valence electrons in group 13? Okay, remember, this is the P block, isn't it? This is S and this is P. So here, this is an S2P1, so that's why it has 3 valence electrons. Then we've got 4, 5, 6, 7, 8, except for up here, which is 2, but that's a full set, isn't it? So knowing how many valence electrons is going to help you with the oxidation number. The oxidation number is something that you must know. You've got to do this. There's no other way around it. Everything in group 1 has 1 valence electron. How many valence electrons, typically, does an element want to have a full set? 8. So if they've got 1 valence electron, it could gain 7 or lose 1. What sounds easier? Losing 1. So everything in group 1 will have an oxidation number of +1. I'll put a 1 here, even though you're not supposed to write the 1. So everything in group 1 has an oxidation number of +1. Everything in group 2 has an oxidation number of 2+. Okay? Group 3. 3+. Okay, when you come to 4, is it easier to gain 4 or lose 4?
It could be both.
It could be either. It's one that you'll have to memorize. Don't worry about it. It is actually 4+, so what do? They lose 4. Okay? Now, group 15, what do you think? Gain 3. What is the charge if you gain electrons? negative. How many electrons does it gain? 3. So everything in group 15 is a 3 negative. What's 16? 2 negative. I'll write a 1, 1 negative. What about the last group? They're full, so they don't gain or lose. Their oxidation number is 0. All of the positive ions have special name. They are called cations. Those are positively charged ions. The negative ions are called anions. Cations will always bond with anions. You will not have sodium and magnesium. Sodium and magnesium are here. Sodium, magnesium. Those will not form an ionic bond because they're both positive. They're going to repel. They've got to match up with an anion. One of the important things about notation when you're writing formulas or names is the cation is written first, and then you write the anion. That's important. Opposites attract. So this positive ion and this negative ion are going to get together and form a compound. So just write the symbol of the cation, write the symbol of the anion, and now the one important thing is to check the oxidation numbers. What's the total positive charge in this compound? +1. What's the total negative charge in this compound? So what's +1 plus -1? 0. This is a really important rule. When you are finished with the compound, the oxidation number must be 0. Think of them as little tiny magnets. They're going to keep sticking together until the whole thing is neutral. All compounds are neutral. Write that down. All compounds are neutral. This is how you talk your way through these. What's the oxidation number for sodium? +1, right? We did that. What about oxygen? -2 because it's, you could say group 16, but how many away from the noble gases is it? 2. And we write the number first. So the oxidation number for oxygen is 2 negative. So I write the formula below, NaO. That's a terrible O. That's right. If you look at the charges, what is the total positive charge in NaO? 1. What's the total negative charge? 2 negative. Is it neutral? Absolutely not. What do I need to make it neutral? I need another sodium. We need another 1 plus. We need another positive charge. So to say I have 2 sodiums and 1 oxygen, yeah, I'm literally going to have this. Now that I've written it out, do you see that the oxidation numbers, this is how they add up to neutral? So I write it exactly as I did before. And the way to tell me I have 2 sodiums is by using subscripts. That is a number below, and it's written after the element that you're talking about. That is the only thing you're allowed to use. When you write ionic formulas, you use subscripts. What's not subscript? What's the top number called? Good, superscript. What is the superscript called? Oxidation number. What does it represent? Charge of the ion. And you can figure it out by looking at the periodic table or the number of valence electrons. Down here in this formula, this is called a chemical formula. The only number you are allowed to use is a subscript. There is another number up there I didn't write. What did I not write? What? The 1 after oxygen, okay? So in a formula, subscripts only. That's important. If you can't remember, get a tattoo. So to work this out, what is the oxidation number for aluminum? 3 plus. It's in group 13, so it's 3 plus. Sulfur is, yeah, it's 2 away from the noble gases, 2 minus. So if I have one of each of those, does it work? No, I need more sulfur, so I have 2 sulfurs. Now does it work? No, so you add another. Yeah, remember the whole least common multiple and all that business? Okay. This way is nice and easy. Little shortcut for you. There's the compound, aluminum and sulfur. You just write the cation first, the anion second. What do I need to add to that compound to make it neutral?
Number 6.
I need numbers written as subscripts. What does the subscript tell you? How many there are. Okay, watch this. This is easy. The 3 comes down here as a subscript. The 2 comes down here as a subscript. So that means I have 3 sulfurs. What's the total negative charge if I have 3 sulfurs? 6. -6. If I have 2 aluminum, what's the total positive charge? 6, and now it's neutral. This is called the crisscross method. It'll always work. Only subscripts at the bottom, though. So there is my completed formula, ionic formula. So the transition metals can have different oxidation numbers depending on what compound they're in. The way to know the oxidation number is by the name. We use Roman numerals which tell you the oxidation number of the transition metal. This is only for transition metals. So in the names, which we'll go over tomorrow, you have Roman numerals. The Roman numeral doesn't tell you how many atoms, it tells you the oxidation number. Now, all transition metals do this. Don't forget, there's a rule in chemistry that there's an exception to every rule, except for a couple of exceptions where there are no exceptions. One of the exceptions is that there are quite a few transition metals, and if you look closely at the periodic table here, you can figure it out. There are some that don't transition, and that's okay. There's nothing wrong with that. Sounds like Seinfeld. There are 3 of those that I expect you to memorize. There's something like 5 or 8 of them that don't transition, that are not variable. So the 3 transition metals that don't transition, that I expect you to know, memorize, if you can't memorize them, get a tattoo, are aluminum, zinc, and silver. Their oxidation numbers are always 3, 2, 1. So when we're naming these transition metals, they don't get Roman numerals. So you won't see Roman numerals for these 3. There are a few other metals, the transition metals that don't transition, but I'm not going to make you memorize them. We're just not even going to deal with them. Okay? What does the word poly mean?
More than 3.
Many, more than 2 actually. Atomic. Atoms. More than 2 atoms. They are ions with more than 2 atoms, or 2 or more. This is called a sulfate ion. It is a particle made of 1 sulfur, 4 oxygens. It is a particle that you're not allowed to break up. You can't do anything with, and it's got a charge of -2. It acts just like the ions we did before. What's the difference?
There's so many negatives.
It's an ion. When you put it in a compound, it'll be neutral. The compound will be neutral. It's an ion with a charge of -2. What's the difference? More than 1 atom. That's all a polyatomic ion is. You treat them just like before. What you probably should do at the very beginning is put parentheses around every polyatomic ion. Eventually you'll realize when you don't need parentheses, but it's a nice safety net, is to use those. So how do we use it in a compound? How do we write a formula? This is how. I'm going to give you a name, and you're going to write the formula for this. So you ready for it? This is how we're going to do it. We're going to write the symbol for aluminum, And it's not aluminum atom, it's an aluminum ion. So what's the charge for aluminum? 3 plus. How do you know that? Group 13, it's one of the 3 transition metals that don't transition, so you have to memorize it. Sulfate, here's your clue. 8 ain't on the periodic table. Great. Hope we don't lose it. That's all right, this is still... I really, really want you to hear that, whether the projector goes out or not. 8 ain't on the periodic table. All of the stuff all of the ions on the periodic table end in "ide," I-D-E. If a name ends in "ate" or "ite," I guarantee you it's what's called a polyatomic ion, and you look it up on a chart. I'm recording audio here, so you just have to hear that I've got a polyatomic ion chart, which I'll give you. The periodic table you use on tests and quizzes has one on the back. So all you do is you look at the chart and you say that, oh, sulfate, that is, let's use pen, SO4, and what's the oxidation number? You look it up on the chart, it's 2 negative. If I have one aluminum ion and one sulfate ion, is it neutral? No. It'd be a positive 1, right? So I need to figure out a way to have more than one, and that's the crisscross. So I'm going to rewrite, I'm going to put aluminum, sulfate here, put sulfate in parentheses. Seriously. What number is going to come down here? 3. So I put a 3 outside the parentheses. That 3 means there are 3 of those things in the parentheses. In this case, what's the thing in the parentheses? SO4 called sulfate. What comes down here? 2. So I write a 2. So the formula...
But you don't read down the...
No charges. The formula for aluminum sulfate is Al2SO4 3. That says that I've got 2 aluminum ions. I have 3 sulfate ions. There's the 3. And sulfate is SO4. It's polyatomic ion. Okay, this is neutral. In this formula, there are no superscripts, only subscripts. Okay?